Chemical effects of electric current. Introduction. We use electricity in our homes to operate different electrical appliances such as fans, bulbs, heaters, doorbells, and various other things. These devices make use of two different effects of electric current. These are the magnetic effect and heating effect of an electric current. Another widely used effect of electric current is its chemical effect. Here, we will study about the chemical effects of electric current. Electric current. Atom is electrically neutral and is made up of positively and negatively charged particles. The positively charged particles, called protons, are heavy and remain fixed in their position. The negatively charged particles, called electrons, are lighter and freely move about. The number of positive and negative charged particles in an atom are equal. When a glass rod is rubbed on a piece of silk, some electrons from the glass rod get transferred to the silk cloth. Thus, the glass rod becomes deficient in electrons and acquires a positive charge. The silk cloth gains excess electrons and acquires an equal negative charge. Electric charge can be made to move in a continuous stream or current. The flow of electrons in a material is known as an electric current. For electricity to flow, we need freely moving electric charges. For those solid which are good conductors of electricity, the moving charges are a type of particle called electrons. In liquids, the moving charges are called ions. Ions are atoms or group of atoms with a positive or negative charge. These ions make it possible for electric current to flow. Two components are necessary for an electric current to flow. Firstly, a continuous unbroken path or circuit is needed for the current to flow through. A switch is inserted in the circuit to make or break the circuit as required. Secondly, we need a driving force called electromotive force which pushes the electrons that carry the charge around the circuit. This force is provided by an electric cell in a circuit. The electromotive force is provided by an electric cell or a generator. Direction of electric current. Electrons flow from a region of their higher concentration to the region of their lower concentration. This means that electricity flows from the negative terminal to the positive terminal. The electric current is measured in the direction of the flow of electrons. However, earlier it was believed that electricity flowed from positive terminal to the negative one. It was felt that positive terminal is at a higher potential. So, current flows from it to the negative terminal which is at a lower potential. The particles that carry charge along conductors are free electrons. The electric field direction within a circuit is the same way in which the positive charges flow. Thus, these negatively charged electrons move in the direction opposite the electric field. Thus, it is clear that conventional current flows from positive terminal to the negative and indicates the direction that positive charges would flow. The electronic current flows from negative to positive terminal. Electrons are negatively charged and are therefore attracted to the positive terminal. Conduction through liquids. There are some substances which allow electricity to pass through them while others do not. The substances which allow electricity to pass through them are called conductors. while those which do not allow electric current to pass are called insulators. All metals are generally good conductors of electricity. Substances like air, wood, plastic are examples of insulators. Now, the question arises whether liquids conduct electricity or not. Some liquids are good conductors of electricity and some liquids are poor conductors of electricity. Most liquids that conduct electricity are solutions of acids, bases, and salts. Here is an activity to make a tester for conductors and insulators. Make an electric circuit consisting of a cell and a bulb connected through insulating copper wire as shown in the figure. Touch the free ends of the wire together for a fraction of a second. If the bulb glows, your tester is ready and working. To test whether a given substance is a conductor or insulator, connect it to the two free ends of the conducting wire. If the bulb glows, the substance is a conductor. If it does not glow, the substance is an insulator. Here is an activity to show conduction of electricity through various liquids. Take small quantity of distilled water, common salt solution, tap water, well water, and kerosene. We may use the tester prepared in the previous activity. The two free ends of the wires of tester are dipped in different liquids to check whether they conduct electricity or not. If the bulb glows, they conduct electricity, else they do not. Caution: the ends of the wires should be washed and dried before being used again. Here is an activity to show conduction through liquids. For this, you need a compass needle, empty matchbox, 2 electric cells, some wires, plastic bottle cap, and liquids to be tested. Keep the compass needle inside the empty tray of matchbox and wrap a couple of rubber bands around it. Connect the wires to the battery and immerse 2 wires in liquid which is kept in the plastic bottle cap. You will observe that when the current flows through the wire, there is deflection in compass needle. It shows that liquid conducts electricity. Although distilled water is a poor conductor of electricity, as it does not have free ions to conduct electricity, but when salt is dissolved in it, it becomes a good conductor. Tap water also conducts electricity because tap water is not pure water and has some salts dissolved in it. The passage of electric current through a conducting liquid causes chemical reactions. The resulting effects are called chemical effects of electric current. While testing liquids, you may find that the bulb does not glow as brightly as in case of metals. This is because the current through liquids is generally weak, as liquids are not as good conductors as metals. So for testing conductivity through liquids, we can use an LED, light emitting diode, in the circuit instead of a bulb. An LED has 2 wires attached to it, which are called leads. One lead is slightly longer than the other. It must be kept in mind that while connecting to a circuit, the shorter lead is connected to the negative terminal of the battery and the longer lead is connected to the positive terminal. It must be ensured that free ends of the lead do not touch each other. Electrolysis. It was found by Sir Humphrey Davy that when electric current is passed through certain substances, they undergo a chemical change to give a new substance. This process is called electrolysis. Let us perform an activity to see what happens when electric current is passed through water. When electric current passes through a conducting solution, it dissociates the solution. The solution that conducts electricity is called an electrolyte, and the process by which an electrolyte is dissociated with the help of electricity is called electrolysis. When an electrolyte is dissolved in water, it breaks up into positively and negatively charged particles, called ions. The positively charged ions are called cations, whereas negatively charged ions are called anions. During the passage of electric current through the solution, the cations move towards the negative charged electrode, cathode, and anions move towards the positively charged electrode, anode. This results in a chemical change. Here is an activity to demonstrate chemical effect of electric current on water. Take 2 iron nails and wrap 1 or 2 rounds of copper wire around them and connect the other ends of the wires to the 2 terminals of an electric battery. Take water in a beaker and add a little salt or few drops of sulfuric acid to it to make it conducting. Immerse the nails in the solution, which will now behave as electrode. You will find small bubbles of gases coming out from the water near the nails. The gases evolved are hydrogen and oxygen because electric current breaks water into its constituent gases, hydrogen and oxygen. It shows that electric current has chemical effect on water. Here is an activity to show that pure water does not conduct electricity. Take 3 small pieces of copper wire, a dry cell, a bulb, and some distilled water in a beaker. Connect the bare ends of the copper wire A, B, and C through the bulb and cell as shown in the figure. Now, dip the 2 bare ends of the wires B and C in distilled water in the beaker. You will observe that the bulb does not glow. It proves that pure water does not conduct electricity. Now, add some common salt to the distilled water. Dissolve the common salt by stirring it with glass rod. When the conducting wire is dipped in this solution, the bulb lights up. It clearly proves that the addition of salt makes distilled water a good conductor of electricity. This activity can be repeated using acids or alkalis instead of salts. You will find that addition of alkalis or acids make the distilled water a conductor of electricity. So we can say that most liquids which conduct electricity are solutions of acids, bases, and salts. Electroplating. Electroplating is the process of coating a metal with a thin layer of another metal by electrolysis to improve the metal's corrosion resistance. The metals most commonly used in plating are copper, nickel, gold, silver, zinc, tin, and chrome. In process of electroplating, a thin layer of metal, generally an expensive one, is coated on an inferior quality metal. Some common electroplated articles are jewelry, chromium-plated motorcycle handlebars, tin-plated cans. Electroplating is done to protect the metal from corrosion or to make it look attractive. For electroplating, the metal to be electroplated is connected to the anode, and article on which a thin metal coating is to be applied is connected to the cathode. The electrolyte should be a solution of a salt of the metal. Here is an activity to show electroplating of copper. Take a glass beaker, thick copper wire, a metal spoon, battery, copper sulfate solution, and copper wires. Fill the beaker with copper sulfate solution. Hammer the copper wire to flatten it out and connect the copper wire with the positive terminal of the battery. Connect the spoon through which a switch to the negative terminal of the battery. Dip both of them in the beaker containing copper sulfate solution, making sure that they do not touch each other. Put on the switch and let the current pass through the solution. After an hour or so, you will see that a layer of copper gets deposited on the spoon. This means that copper gets transferred from one electrode to the other. Applications of electroplating. Electroplating is widely used in industries for coating metal objects with a thin layer of another metal. The layer of metal deposited had some desired property which the metal of the object lacks. Example, chromium plating is done on the objects like car parts, bath taps, kitchen gas burners, bicycle, handlebars, wheels, rims, and others. Chromium has a shiny appearance. It does not corrode and resists scratches. However, it is expensive and may not be economical to make the whole object out of chromium. So, the cheaper metal is used and only a coating of chromium over it is deposited. Jewelry makers electroplate gold and silver on less expensive metals. These ornaments have the appearance of silver or gold but are less expensive. Tin cans used for storing food are made by electroplating tin on iron. This process is known as tinning. Thus, food does not come in contact with iron and is protected from getting spoiled. Iron is used in bridges and automobiles to provide strength. However, iron tends to corrode and rust. So, a coating of zinc is deposited on iron to protect it from corrosion and formation of rust. This is known as galvanization, and the product is called galvanized iron, GI.